Some places don't look important until the world realizes they hold the keys to the future. That's the case with Canada's Arctic. For most of history, it was just ice, snow, rocks, caribou, and even more ice. But now, it's about to become one of the most important places on Earth, and maybe make Canada a global superpower. Why? Because it's hiding minerals that power electric vehicles, satellites, and missile systems, while the demand is skyrocketing. However, it's not just mining and having resources, it's also about control. Right now, China has a massive head start because it refines over 90% of the world's rare earths. That means if you want to launch a satellite, manufacture advanced electronics, or even just keep the lights on in your fancy smart home, odds are you're relying on China. And that makes a lot of world powers very nervous. Because when everything's going electric, the last thing you need is being dependent on your geopolitical rival. So now, the global clean tech treasure hunt is officially on. The US, Europe, Japan, Australia, they're all competing. However, the latest technology and untapped potential might give Canada the upper hand. Canada's had these minerals for decades, but with low prices, tough terrain, and no global rush, they mostly stayed untouched. However, Ottawa is finally stepping up its game. Back in 2022, Canada rolled out the Critical Minerals Strategy with billions in funding and tax perks to get companies digging. There's also plans to build the necessary roads, ports, and power lines to tap into those remote deposits up north. Canada already produces more than 60 minerals and metals, but 31 of them are now considered critical. 6 of those are having VIP treatment: lithium, graphite, nickel, cobalt, copper, and rare earth elements. But digging it up is just step 1. The real plan? Keep it local. Melt that frozen treasure into shiny new batteries right at home. That means not just mines, but also refineries, processing centers, and high-tech factories popping up where there used to be nothing but snowdrifts and silence. While others are talking, Canada's busy paving roads and stringing power lines. Slowly but surely, they're turning snowfields into a high-tech playground. Getting to all that buried treasure used to be nearly impossible. After all, we're talking about land so remote that roads literally stop hundreds of miles too early. The ground is frozen solid for most of the year. And even if you found something valuable, just getting out was a logistical nightmare. So what changed? Canada has an ace up its sleeve. Don't know about you, but I use it mainly for making memes and music. But geologists? They're scanning the Arctic like it's Minecraft with X-ray vision. Instead of drilling blind, they're using decades-old core samples, plugging them into AI, and getting shockingly accurate predictions about what's underground. It's like upgrading from a pirate's treasure map to a GPS that actually says, "Dig here." Companies like Geologic AI and Cobalt Metals are already doing this, pouring data into AI and getting X marks the spot hits for nickel, cobalt, and rare earths. In the Northwest Territories, Canada is running a pilot lab that uses AI and digital scanning to reanalyze decades-old rock samples. The goal is to spot hidden mineral deposits that old methods might have missed without digging a single new hole. All that sounds great, but maybe I made it sound simpler than it is. Digging up the Arctic is a logistical nightmare. For starters, this isn't just a remote patch of land. The Canadian Arctic is huge. Almost half the country, stretching over Yukon, the Northwest Territories, and Nunavut. We're talking about a region larger than India, with fewer people than a small city. Most of it is permafrost, wilderness, or ice-covered islands scattered across the Arctic archipelago. Temperatures go from barely 50 degrees Fahrenheit during summer to negative 40 degrees Fahrenheit or colder, with ground that stays frozen for most of the year. Fun fact, did you know that negative 40 degrees happens to be the same as negative 40 degrees Celsius? It's the one temperature where both scales intersect. They climb at different rates, but eventually cross paths when it gets cold enough. Just a small trivia nugget for weather nerds like me. Anyways, you can't just roll in a truck and break ground in the Arctic. Up there, roads just stop. Want to build something? It can take years. and one nasty winter can put everything on ice. And if you want to continue up north, you need more of everything. More food, more fuel, more machines, which means even more money. Speaking of money, another chilling fact is how much this all costs. Mining in the far north is way more expensive than doing it in, say, Australia or Chile. An AI might tell you where the minerals are, but people and big machines still have to dig, and that costs a fortune. But that's not all. Most of the Canadian North is Indigenous land. First Nations, Inuit, and Métis communities have lived there for thousands of years, and mineral hotspots often sit right on their ancestral grounds. So when Canada talks about unlocking the Arctic, it's not just a question of roads and robots. It's a question of partnership and collaboration. And that's not optional. Legally, projects on Indigenous land require consultation and, in many cases, consent. The good news, some communities aren't just involved, they're leading the way. In regions like Nunavut and the Northwest Territories, Indigenous-owned corporations and world powers are already shaping how development happens on their terms. If Canada wants to pull this off, it's going to need more than tech and funding. It's going to need trust. So with all that in mind, can Canada pull this off? Honestly? With technological advancements and partnerships, it doesn't seem impossible. But Canada isn't just doing one thing right. It's doing a bunch of things at the same time. Let's recap. Hidden resources? Checked. New strategy? In place. Big funding? Approved. AI tools? Deployed. Indigenous partnerships? Underway. Infrastructure? Already breaking ground. It's a snowball turning into an avalanche. Exploration boosts investment. Investment speeds up roads. Roads unlock more deposits. More deposits attract more factories. It's a feedback loop, and if they keep feeding it, the whole Arctic operation could go from an idea to empire faster than anyone expects, giving a whole new meaning to the phrase frozen assets. But this doesn't just help Canada. It could save the US a whole lot of trouble. If all goes to plan, the US won't need to ship rare earths halfway across the planet. It can just look north, wave at the caribou, and get what it needs from its closest neighbor. That's why the US has publicly backed the effort, offering support and funding to help build a trusted North American supply chain. For Canada, this could be the moment it stops being just a supplier of raw materials and starts becoming a critical power broker in the clean tech economy. For the US, it's like discovering your neighbor has been secretly building a battery factory in their backyard, while you were building electric vehicles. And globally? Well, the abundance of resources tends to lower the prices, and that's always a good thing for us regular people. Cheaper cobalt, nickel, and lithium mean cheaper batteries, and cheaper batteries mean more affordable electric vehicles, energy storage, phones, laptops, the works. Now, don't get too excited just yet. Like we said, mining in the Arctic isn't cheap, but in theory, once Canada's clean tech engine is fully up and humming, more supply and shorter supply chains should gradually bring costs down. And it's not just about price tags, it's about stability. Right now, if one country cuts exports or gets caught in politics, everything down the line gets shaky. But with Canada stepping in as a reliable supplier, the global system might get a bit more breathing room. Manufacturers can stop sweating over single points of failure and start building with confidence.
Hey, quick question. How many continents are there? 7? Maybe 5? There's no correct answer. According to different approaches, the range is between 4 to 7. But it might actually be as many as 8. Chances are, a lost continent has recently been found between Greenland and Canada. This new continent discovery could also potentially be the key to how microcontinents form. What does this all mean, and what makes this hidden landmass near Greenland so important? Now, if you're like me, and if you are, then there's 2 of us, when you hear the word continent, you probably think of land like Europe or Africa, places above water where people live. But in science, a continent isn't about being above sea level. It's about what the land is made of. Earth's outer layer, called the crust, comes in 2 main types, continental and oceanic. Continental one is thicker, lighter, and made of different types of rock, like granite. The oceanic crust is thinner, heavier, and made mostly of dark volcanic rock. Now, the discovery under the Davis Strait between Greenland and Canada appears to be a piece of continental landmass, even though it's under the ocean. Scientists call it a proto-microcontinent because it began to break off from a larger terrain millions of years ago, but never quite made it. As tectonic plates slowly shifted, the Earth's crust in this region stretched and cracked. One chunk started to split away, but for some reason, the process stopped. It didn't drift off like a full continent, and it didn't sink like ocean crust either. Instead, it stayed right there, floating beneath the waves all this time. This makes it different from true microcontinents, like Zealandia, which have completely detached and now exist as separate tectonic blocks. Zealandia is a submerged microcontinent near New Zealand. About 94% of it lies underwater, but because it's made of continental crust, many geologists say it qualifies as Earth's eighth continent. However, Zealandia is still debated because it's too big to be a microcontinent, and there's no official global body to define its status. There's no global organization like the UN or some kind of international geology council that can declare, hey, this is a new continent. Unlike Madagascar, which is fully above sea level and widely accepted by geologists as a classic example of a microcontinent, Zealandia is still waiting for a proper label. I know you're probably wondering, isn't Madagascar an island? The simple answer is, it's both. It's the fourth largest island in the world completely surrounded by water, but it's also geologically considered a microcontinent because it broke off from the supercontinent Gondwana around 88 million years ago and is made of continental crust, not oceanic crust. Unlike volcanic islands like Hawaii, this isn't just built from lava. It's a real piece of ancient continental crust. So Madagascar checks both boxes: island by geography, microcontinent by geology. And that's exactly why these discoveries can be fascinating. Just like Madagascar stands out above the waves, this newly discovered landmass under the Davis Strait stands out beneath them, thanks to its unusual structure. What makes it stand out is its unusual thickness. Most of the ocean floor is thin, like metal. This is more like packed clay, layered with continental materials. Underneath this cozy comforter, scientists discovered some odd layers of rock, unusual because they're not where they should be. These layers act more like the materials found on continents rather than those typically seen on ocean floors. There are hints of granite-like formations and distinct magnetic properties, which suggest that this stuff is similar to what makes up dry land. The size is also remarkable. The proto-microcontinent is about 12 to 15 miles across, which makes it roughly the size of a mid-sized city, like Manhattan Island at 6,500 feet underwater. The fact that it sits right under the Davis Strait, one of the widest ocean passages on Earth, makes it one of the largest submerged continental fragments we've found. According to researchers, this landmass began to form between 58 and 49 million years ago, when Greenland and Canada were slowly drifting apart. Maybe they just weren't getting along. Hey, it happens. As they pulled apart, the crust under the Davis Strait stretched, and one of the main fault lines shifted. But the breakup didn't finish. Around 48 million years ago, the rifting stalled, and Greenland's motion away from Canada slowed dramatically when it later bumped into Ellesmere Island. It's like a car swerving off and then back onto the freeway, a turn that was never completed. That's basically what happened. A chunk of land got stuck between the motion. It didn't float off into the ocean like a new continent, and it didn't get pulled down into the Earth either. It just stayed where it was, stranded beneath the water. But that's not all. This chunk has its own fault system, and scientists say it actually looks like a miniature version of the San Andreas Fault in California. Now, a fault is basically a crack in the Earth's crust where sections of rock slide past each other. Think of it as a place where the Earth's surface split and tried to slide sideways. In California, this movement still happens today and can cause earthquakes. But under the Davis Strait, it's a different story. The movement started, then suddenly stopped, like hitting pause in the middle of a big shift. It's a frozen moment in the planet's past, preserved right beneath the waves. For geologists, that makes the microcontinent under Davis Strait incredibly valuable. That sudden pause in motion, helps explain why some chunks of land break away cleanly while others twist, stall, or disappear. But this isn't just academic. By studying how continents break apart or stall, scientists can better predict future shifts in land, fault lines, and seismic activity. And predicting earthquakes and geological hazards could prove quite valuable to everyone. Knowing how microcontinents form could help us anticipate how the planet's surface might shift over millions of years, which affects everything from climate models to resource availability. But even just the technological advancement needed for such discoveries is greatly beneficial. The same tools used to map this hidden land are used for oil exploration, laying undersea cables, climate monitoring, and even search and rescue missions. Speaking of technology, for a long time, this hidden landmass near Greenland remained invisible. Just 10 or 15 years ago, the ocean floor under the Davis Strait was basically a mystery. It's deep, almost frozen, obviously not the easiest place to explore. But today, thanks to modern tools, a new continent discovery could be just a matter of time. Scientists can finally see and hear what's going on under all that water. First, they use seismic reflection imaging. That's a method where ships send sound waves down to the ocean floor and record how they bounce back. Various layers of rock reflect sounds in different ways, which helps build a picture of what's hidden underneath. It's kind of like how bats use echoes to see in the dark. Satellites also play a role in collecting gravity data. This may sound strange, but different types of rocks have slightly different weights. Heavier rocks create stronger gravitational pull, and satellites can measure those tiny differences. Another tool commonly used for these explorations is underwater sensors, which sit quietly on the seafloor and listen for natural vibrations, like mini earthquakes or shifts in rock. These vibrations help scientists figure out what the crust is made of and how thick it is. They're basically ears on the ocean floor. They also most likely used AUVs, or autonomous underwater vehicles, basically robot submarines that can scan the seafloor in high resolution even under thick ice. In any case, scientists are very excited because this new continent discovery is more than just a geological surprise. It's what they call a natural laboratory. The study of the microcontinent Davis Strait offers a rare opportunity to understand how microcontinents form, evolve, and sometimes fail to fully separate. It also reminds us that Earth's crust isn't as neatly divided as we once thought. Beneath the ocean, there may be other hidden landmasses near Greenland or elsewhere, almost continents just waiting to be found. This lost continent of Canada may not have made it as a fully fledged landmass, but its discovery is already reshaping how we view plate tectonics. And thanks to advances in technology, places we once ignored are now offering up secrets about the planet's deep past, and maybe even its future. That's it for today. So hey, if you pacified your curiosity, then give the video a like